In this problem, we're being asked to graph an absolute value equation, and the equation they're giving us looks pretty complicated. There's a lot going on there. What I'm going to do is just start by graphing the basic function to make sure we all know what this looks like. This is the basic shape that our new graph will be based on. If you haven't seen the absolute value of x before, in fact, if there's any function you haven't seen before, one strategy you can use is to make a chart here of the x and y values, get some points, and start putting them on the graph. So we'll do that. 0 is often a good point to start with. So let's try putting in x, 0 for x. Well, the absolute value of 0 is just 0, so y would equal 0. And that's actually going to be our vertex of this function. So let's just plot that right there. And then I'm going to put in a 1. Well, the absolute value of 1 is just 1. I'm also going to put in a negative 1 because this is what the absolute value does, is it takes negative values and turns them positive. So that's just going to be a positive 1. So we're going to get this point and this point. And if we went on with 2 and negative 2, both of those would equal 2. So what you can see is we get these kinds of pairs of points. And if we continue on with that, we'll get this sort of V-shape, two arms, V-shape kind of thing. So that's y equals the absolute value of x. Let's talk about what these different numbers do to this basic function. First of all, we've got this minus 2 hanging off the end here. It's not inside the absolute value symbol. It's just hanging off the end. This number moves the whole function up or down. A minus 2 means down 2. So we can translate our vertex down 2 to take care of that part right there. The other part that helps you locate the vertex is what's inside the absolute value symbol. Here we have a plus 4. The number here inside the absolute value symbol moves the function left or right. A positive value moves it left. So we're actually going to move left 4 spaces. So our vertex for our new function is going to be right there. In fact, let me just put that over here on this graph. So this is the point -4, -2. Now, we're going to have a slightly different shape because we've got this 4 multiplied out here. What this number multiplied by the absolute value part does is it squishes it or stretches it. Makes it kind of more steep or more shallow depending on the number. Maybe what we should do is just make another chart here. We've got our vertex, right? So let's just put that in. So -4 gave us -2. And then let's do what we did here by choosing points on either side of the vertex. So our vertex, the x value is at -4, so let's find the x value at -3 and -5, or let's choose those for x values and find the y value. So let's put those in. So if I put in a -3 here, -3 plus 4 is 1, absolute value of 1 is 1, times 4 is 4, minus 2 is 2. So -3, 2. Now, -5, I think, should be the same thing because this is the points on either side of the vertex, but let's just try it. A -5 plus 4 is a -1. The absolute value of that is positive 1 times 4 is 4, minus 2 is 2. Aha. Yeah, so that pair of points seems to work out. Let's go ahead and plot those. So -5, 2, and -3, 2. And let's go one more point on either side. So that would be a -2 for x or a -6 for x. These should also have the same y values. So -2 plus 4 is 2, times 4 is 8, minus 2 is 6. And a -6 plus 4 is a -2. Absolute value of that is a positive 2 times 4 is 8, minus 2, 6. Awesome. All right, so let's plot those. -2, 6. And -6, 6. All right, so what you can see if we sketch in our lines now is we've still got that basic V shape. It's just that our vertex has been translated down and to the left, and the whole shape has been sort of squished. You get a steeper kind of V here. So that is a little bit of work with graphing an absolute value equation.